We have looked at the properties of rectangles, squares, and rhombuses. So now we're going to look at the certain conditions that must exist for a figure to be a rectangle or a square or a rhombus. So what conditions guarantee the figure is a rectangle, square, or rhombus is our essential question. Learning intention. I'm learning to use the properties of quadrilaterals to determine what type of quadrilateral it is. So find the indicated measure of the following rhombus. So what are the properties of a rhombus? Well, one of them is that your diagonal bisects opposite angles. Another is that all of the sides are congruent. So using those two characteristics, those two properties, pause the video and see if you can do the warm-up now. Well, I do hope that you tried. So if we're looking at this, if this angle is 106, we know that these two angles are congruent. So we've got 180 degrees minus 106 degrees, and that leaves us with 74 degrees. But that 74 degrees is for both of these. So once again, I have to divide 74 in half to find the measure of 1. (74 divided by 2 is 37. 8x minus 3 is equal to 37. Add 3 to both sides. Eight x is equal to 40. Divide both sides by 8, and x is equal to 5. So when x is equal to 5, the two bottom angles are each 37, and you end up with that, right, the figure being a rhombus. Another way you can look at it is when we divide this in half, we have an isosceles triangle, and the base angles have to be congruent. What about the next one? What do we know about the length of the sides? They're all congruent. If they're all congruent, then -3 plus 6x is equal to 1 plus 5x. Now we solve. Subtract 5x from both sides. -3 plus x is equal to 1. Add 3 to both sides, and x is equal to 4. So if I'm looking at this, 5 times 4 is 20, 20 plus 1 is 21. Okay, so all the sides have a length of 21. Okay, what happens though if we're on a Cartesian plane? We can't, especially if it is not running straight horizontally or straight vertically. We cannot look at it and determine, without doing some math, whether or not it is a rectangle, rhombus, or square. So to be a rectangle, it tells us it's a parallelogram, so we know that opposite sides are parallel and congruent. But to be a rectangle, what do we know about the corners? they have to be 90-degree angles. So I am going to look at the slope. I can do PQ and either QR or PS to determine whether those slopes are opposite reciprocals. If they're opposite reciprocals, then I know that I have perpendicular lines. So my point P is -2, 3. My point Q is 0, 5. Okay, I can do Q and R or I can do P and S. It does not matter. Okay, I'm going to choose QR, so I need R. R is 4, 1. So let's look at slopes now. If I'm looking at the first one, 3 minus 5 over -2 minus 0. That gives me -2 over -2, which is +1. So if they're going to be opposite reciprocals, I better get a -1 for the next slope. Between Q and R, 5 minus 1 over 0 minus 4. 5 minus 1 is 4. 0 minus 4 is -4. I have a slope of -1. Those are opposite reciprocals. I know that I have a right angle. Now, if I have one right angle, what happens? Well, these two add up to 180 degrees because they have to be supplementary. So this one has to be 90. These two also have to be supplementary. So we know that I've got 90-degree angles all the way around. And they are perpendicular. That's how I know they're 90 degrees. Okay, to be a square, we know that the length of all the sides has to be the same. If I'm looking at this, it's fairly easy to determine that the sides are not the same. But we actually use what we call the distance formula to make sure. I need to find point S now, and that is 2, -1. So I'm going to look at the distance. We know it's a parallelogram, which means opposite sides are congruent. So I'm going to look at the distance or the length between P and Q, and then between Q and R. And if they are both the same, then I know I've got a square. Do you remember the distance formula? D is equal to the square root of x minus x squared plus y minus y quantity squared. Okay, so -2 minus 0 quantity squared plus 3 minus 5 quantity squared. So this is going to be -2 squared is 4. -2 squared is 4. So this is the square root of 8. Do you remember how to simplify? We have to find that prime factorization. So I've got a pair of 2's. This becomes 2 square root of 2. That's the length between P and Q. Let's look at the length between Q and R. 0 minus 4, quantity squared, plus 5 minus 1, quantity squared. Okay, this will be negative 4 squared, which is 16. This is positive 4 squared, which is 16. 16 plus 16 is 32. Even before we simplify, we know that those are not the same length. To simplify the square root of 32, divided by 2 is 16. Divided 16 by 2 is 8. Divide 8 by 2 and it's 4. Divide 4 by 2 and it is 2. Divide 2 by 2 and it is 1. When you get to 1, you're done. I have one pair of 2's, I have a second pair of 2's, and I have one left over. 2 times 2 is 4. 4 square root of 2. So it is not a square or a rhombus. Okay, now let's start thinking. Is this enough to determine what kind of parallelogram I have? If the diagonals of a parallelogram are perpendicular, then the parallelogram is a what? If you said rhombus, you would be correct. If one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. Can I also say it's a square? Is that condition enough to say it is a square? No, because we have to know at least 2 of the sides are congruent, and we don't know that any are. With a rhombus, we know that when the diagonals are perpendicular, that is a characteristic. Okay, so if one diagonal of a parallelogram bisects an opposite pair of angles, then the parallelogram is it a square? We don't know. Is it a rectangle? I don't think so. Is it a rhombus? Yes. So the next question is that enough to say it's also a square? No. If it said both diagonals bisected the opposite angles, it would be, because then that would be pulling it into where the diagonals would have to be congruent, and if the diagonals are congruent, then it's a rectangle, and if they bisect, then it is a rhombus. A rhombus plus rectangle is a square. Okay, find the indicated variable to ensure that the figure is A. So it's going to say what it's supposed to be, and then you have to decide how to use that. To be a rhombus, what do we know about our diagonals? Well, we know our diagonals are perpendicular. So 4x plus 22 must be equal to 90 degrees. Solve for x. Subtract 22 from both sides. 4x is equal to 68. And that's 68 degrees. Divide by 4. And x has got to be equal to 17 degrees. Now, because my brain is saying, oh, that doesn't look right, 68 divided by 4 is 17. I double checked it with the calculator after doing it myself. Okay, so we've got a square. We're looking at AC. What is AC? AC is one of my diagonals. And we're also looking at BD. What is BD? BD is the other diagonal. What do we know about the diagonals of a square? They are congruent. If they're congruent, that means 17 is equal to 4x minus 3. Now we solve for x. We start by adding 3 to both sides. 17 plus 3 is 20. 20 is equal to 4x. Divide both sides by 4. And 5 is equal to x. Okay. Can you do the next one on your own? To make it a rectangle, what do we know about 8x plus 18? To be a rectangle, what do I know about all my corners, all my angles? They are all 90 degrees. Set it up. 90 degrees is equal to 8x plus 18 degrees. Start by subtracting 18 from both sides. Okay, so that would be 72 degrees is equal to 8x. Last step, divide by 8. 72 divided by 8 is 9. So 9 degrees is equal to x. I hope you tried and that's what you ended up getting when you solved. Okay, on the next one, what do we know about a rhombus? If you said all the sides were congruent, you would be correct. So if I'm looking at this, I know these two sides are equal, they are congruent. So 2x plus 1 has got to be equal to 4x minus 13. Solve for x. Subtract 2x from both sides. 1 is equal to 2x minus 13. Add 13 to both sides. 14 is equal to 2x. Last step, divide by 2. 7 is equal to x. Okay, now, how do you know you're successful? You know you're successful when you can use the properties of quadrilaterals to determine what type of quadrilateral it is. So these are conditions for rectangles, squares, and rhombus. I'm going to call them rhombi just because I like that word.